Today I'm going to show you how to analyze a pattern of holes from the Reaction Plan Manager++ software solution. RPM is designed to give the operators on the shop floor specific instructions to adjust the manufacturing process. Unfortunately, evaluating hole patterns from this application is difficult. You must analyze all the holes in the pattern together to properly calculate the adjustments. The bulk pattern analysis software, on the other hand, is designed specifically to perform that task. It will evaluate multiple parts, group measurement data in patterns, and calculate the optimal adjustments for hole patterns. The ideal solution is to use both software tools on the shop floor to control the process. Using RPM, you can start and share data with the bulk pattern analysis software. And that's what I'm going to show you in this video. As you can see, we have the Reaction Plan Manager++ software running, and we have a simple hole location example loaded, a solution loaded. This particular solution has a 6-hole pattern, and we're monitoring the true position and diameter of each one of the holes. Over here on the left, you can see we've got machine A, machine B, and machine C. So we have 3 different reaction plans, or 3 different processes that we're monitoring. You'll notice that machine A is green, which means there are no rule violations, so it's good. We don't have to do any adjustments. Machine B has some issues. If I click on machine B, you can see that true position 1 TP and 6 TP, so holes 1 and 6 have some issues, so we need to make some sort of adjustment on machine B. And machine C is green and it's good, so we don't have to worry about machine C's process. You'll also notice that there's a button here called the bulk pattern analysis. If I click on this button, it will start the bulk pattern analysis software and open up a solution which contains the data for machine A, machine B, and machine C. I'm going to select the bulk pattern analysis button and watch what happens. The bulk pattern analysis software was started, and a solution automatically built using data collected from the Reaction Plan Manager++ software. I did nothing special to do this. All I did was click on that button, and this all happened automatically. I can now evaluate the machine A and machine B and machine C process by just clicking on the individual choices here. The bulk pattern analysis software will display a pattern and show you the individual parts in the pattern. The dashed lines or the dashed circles represents true position tolerancing zone scaled up. So you can see I've got 6 targets here, or 6 true position zones in which we're trying to target our machine. And here you can also see we've got 4 parts that we're evaluating in this process. Up here on the left, you have the error. So the pattern error is 0.0009 in X, 0.0001 in Y, and we've got a rotational error of 0.0081. The error represents the pattern error. This is how much the pattern is off from being on target. You're probably wondering why there's 2 rings around each one of the targets. The outside ring, or the outside circle, represents the maximum material condition for that particular hole. So if you include the diameter information in the analysis, the software will calculate the minimum maximum material condition for that feature based upon the data that was given to it. Now, clearly we don't really care about machine A or machine C because we know those 2 machines are good. We really care about machine B. So if I click on the machine B item here, we can see that the hole pattern has more error in X, more error in Y, and a larger angular error. So the pattern is shifted and rotated to the point where it's actually reached an out of tolerance condition. So now we need to make some adjustments to this. With the bulk pattern analysis software, I can click on Control and simulate a best fit. So if I click on the best fit button here, it will do the math for you and calculate the optimal adjustment value. So here you can see if we correct the process by shifting by a minus 0.00215 in X and a minus 0.00275 in Y and clock it by minus 0.03196, it would yield a desirable result. So that would target the machine. If I were adjusting the machine, these are the exact numbers I'd punch into my process to fix the process. If I click on the Home button, it'll send the data back to its original position. Now you're probably wondering why I've got parts that are out of tolerance in the bolt pattern analysis software. However, in Reaction Plan Manager++, I don't have an out of tolerance condition. It's set to yellow, which means we've reached the percent of tolerance criteria. We violated the percent of tolerance rule violation. Well, the reason is that we're looking at the average of the last 4 parts. So if we were to expand that, you'll see that it triggered the percent of tolerance rule violation even though I've got parts that are out of tolerance. These are configurable items in the software. I mean, I could set this up to look at to react to the last part or the last 20 parts. You'll decide based upon your process how you want to do the analysis. Let's go ahead and measure some parts so you can see what it looks like from an operator's point of view. To simulate a part measurement, I'm going to use the RPM Training CMM software down here at the bottom of the screen. I've got this configured so that it's going to send the data to machine A. So if I click on Inspect, it's as if I've measured the part on a CMM and the data has been measured from the CNC machine A. So if I click on Inspect, you'll see that there's no rule violations. We've got this set up so that it hides the normal criteria, so it's only going to show us a reaction if it's under warning or critical. So let's go ahead and inspect some more parts and actually run this until it actually generates some rule violations. There we go. So here we've got, for machine A, again it's hole 1 and hole 6. So I simply hit the button. The bolt pattern analysis software is already running, so what'll happen is it'll do the analysis. Data went to the bolt pattern analysis software and give us some results. Here you can see I've got an out of tolerance condition, just similar to the other machine B, and I can go ahead and do my best fits and figure out how to adjust my machine. Now you got to remember, this is based upon simulated data. That's why the results are consistent. In this video, I showed you how to analyze hole patterns using RPM and the bolt pattern analysis software. We did a simple example here using 6 equally spaced holes. The reality is this could be a rectangular pattern. It could be holes coming from a transmission case. It could be holes coming from an engine block. It really doesn't matter. If you produce parts with holes, this combination of tools makes the process of adjusting your machine pretty simple. To learn more about these software packages, visit www.beckerqualitysolutions.com and click on the help video links at the bottom of the web page.